We ready? Okay. If you already wrote this, don't write it again. But if you haven't, then write it. This word conjugate, that's how you say it, conjugate zero theorem. Basically what it says is if you have an irrational zero or an imaginary zero, they will always come in pairs. You never ever just have one of them. You will always have pairs. So anything that has a square root or anything that has an imaginary number, they always have pairs. And this is what the pairs look like. If you have one number that's a plus square root of b, then you're going to have another one that's a minus the square root of b. Or if you have a plus bi, you're going to have a minus bi. So write this down. If you know that a polynomial has that 0, 2 plus 4i, just write it down. The point here is to use the theorem and not the P over Q or any of that synthetic division. Use the conjugate zeros theorem to find another 0. So 2 plus 4i looks a lot like this kind of thing right here, this a plus bi. You're never just going to have one of them. They have to come in a pair. So 2 plus 4i, the conjugate pair for 2 plus 4i would be 2 minus 4i. That's guaranteed to be another 0. If 2 plus 4i is a 0, then 2 minus 4i is also a 0. We don't have to prove it using any kind of division or anything like that. It's guaranteed because of the conjugate zero theorem. Okay? So just for practice sake, before we get to the worksheet, I'm going to put up a bunch of numbers up here. Let's just practice finding conjugates real quick. So here's an example. Find the conjugate. Let's have 2 minus the square root of 5. 6 plus 4. Let's just practice finding conjugates of all of them. Should go pretty quick. What do we think? Conjugate for part A. 2 plus the square root of 5. Yeah. Essentially, you're going to figure out this pattern here soon enough. Essentially, all you do is change the sign in the middle. That's all you change is the sign in the middle. 6 plus 4i then, the conjugate pair would be 6 minus 4i. Square root of 3, you're never ever going to have just a single square root type root. There's 0. You're always going to, it's always going to come in a pair. This is the positive square root of 3. So then the conjugate pair would be negative square root of 3. If that's confusing you a little bit, consider this. Do you guys, are you okay if I say 0 plus the square root of 3? Isn't that the same thing? Yeah. Then what would the conjugate pair be? 0 minus the square root of 3, but you don't really need the zeros in there. So then what about negative 2i? Positive 2i. That would be the conjugate pair. -4 minus 2i. Remember, a lot of students will want to change both of the signs. You only change the one in the middle. It's still -4, but it's -4 plus 2i.
So on your worksheet, turn over to the back now. You should have started number 9, 10, and 11, and 12. That's what I asked you to start. Number 9 was what, square root of 5 and 3 minus 3i? Yeah. So then the conjugates would be negative root 5 and 3 plus 3i, right? That was pretty easy. That's an easy section. Were there any questions on 9, 10, 11, or 12 on how to do any of those? Okay. The one that a lot of students have been messing up on is number 11. What's the conjugate of the first one? -1 plus 3i. It's -1 plus 3i. Okay. Now the point of learning this isn't just to learn how to do it. That's easy. This would be easy enough to teach for the second grade. Okay. But the point is what's coming next
isn't quite so easy. It takes a little bit more work. So what I'm saying is, what do you do once you have the other zero or the other conjugate? So let's take a look. Ooh. This is similar to the directions in your homework. It says find any additional zeros and then write the polynomial. So let's say that we had zeros of x equals 2 and x equals 1 minus I.
Let's just go a piece at a time. The first part says find any additional zeros.
And all they mean is use the conjugate zeros there. X equals 2, that doesn't have any conjugate pairs, because it's just a rational number. Only irrational or imaginary. Like this one here, this one's going to have a conjugate pair. It wasn't written on purpose, the pair, because you have to come up with it. What's the other zero? 1 plus I. So that answered the first part. Find any additional zeros. We did that. The second part, write the polynomial. Can get a little tricky. Do you recall this problem from your test that I just gave you back a few days ago? I gave you these 3 zeros. This was on page 2, and then you had to go from here to here, right? And then what'd you do from here?
You had to put it into
You distributed it, and you got something like x to the third plus 10x squared or something like that, minus... I can't remember exactly what it was, but the point was you had to multiply all that together to get to your final answer. You remember that?
Yeah.
Do you remember how much of a struggle it was for some of you? Do you understand it better now? The first time around, man, that was a hard problem for you guys.
Yeah.
It's a little bit easier for you now. Because it's not going to get any easier with this problem. We got to do the same thing. We've got to make 3 sets of parentheses and multiply those all together. Problem is now we're going to have some pretty funky numbers inside those parentheses. Okay? Let's start with this one. X equals 2. What kind of parentheses are we going to give?
2.
X minus 2. Now let me just explain what's happening here real quick, because most of you guys are doing this in your head, which is okay, but you really need to understand how to go from here to here. The reason these are called a 0 is because we need to find a number that makes this equal 0. So if you subtract 2 on both sides, you're going to get x minus 2 equals 0. Once it equals 0, that's what your parentheses is, x minus 2. So if we use that same argument, if I subtracted 1 and then added an I to both sides, then isn't that going to be x minus 1 plus I equals 0? Do you guys agree? That's what your parentheses is. X minus 1 plus I. Now do the same thing here. Subtract the 1 on both sides and subtract the I. So what are we going to have? X minus 1 minus I. Those are the factors. Similar to what we had over here on the test. Once you had the factors, you had to multiply those. So I'm going to try to go real slow on this one. I definitely 100% without a doubt would start by multiplying these two together first. Always, always, always the last two. Or the two that have the weird looking factors. Okay? And it's nothing more than the distributive property. You take the x and distribute the x in the first parenthesis to all the terms in the second parenthesis. So let's at least do that. X times x is x squared. X times negative 1 is negative x. And x times negative I is negative xi. I always write the I first for some reason. It doesn't really matter the order, but I always write it as ix. So it's x squared minus x minus ix. Now we do the same thing with the negative 1. You take the negative 1 and distribute that to all of the terms. So negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. Negative 1 times negative I is positive I. Now we do the same thing with the I. I times x is positive ix. I times negative 1 is negative I. And finally, be careful on this one. This is where I see a ton of mistakes. I times negative I is negative I squared. It acts the same as a variable. X times x was x squared, so then I times I is I squared. If you haven't seen it yet, hopefully some of you have noticed. If you haven't seen it yet, why would I strongly suggest you multiply those two together first?
Because it's easier to tell that what zero that is, right?
It may be, but look at the individual terms. Do you notice anything now that's going to happen? There are a ton of terms that not just combine, they completely disappear, don't they? Negative ix, positive ix, they're gone. What else? Positive I and... Do you notice what is exactly canceling out? Anything that has an I is going away. Isn't that kind of nice? Oh, except for that pesky I squared. Well, here's what we do with that. I'm sure most of you don't recall this. I'd be surprised if you do, but you did learn this last year regarding I squared equaling something. Negative 1, and a couple of you remembered. This was something that was taught last year. I squared really equals negative 1.
So then, what is this right here then? I squared. Now listen carefully. You're subtracting I squared. So you're subtracting negative 1.
So you're really adding 1. So you can even get rid of this negative I squared and put a plus 1 in its place. Minus I squared is the same as plus 1. Now do you see what happened? There are no more i's in this expression. All we have left, or what you would, I guess, call normal algebraic terms. We have an x squared, we have a minus 2x, and we have a plus 2. And you still need to multiply that with the x minus 2. You guys go ahead and give that a try. From here on out, you should be able to finish this.
So go ahead and give it a try. Multiply those two together.
It's the same thing. You start with the x, and you multiply the x here, here, and here, and then you multiply the negative 2 here, here, and here. So go ahead and try that.
Is that what we're getting? Anybody? Somebody? Did anybody get that? Okay, a couple of you did. X to the third minus 4x squared plus 6x minus 4. Kind of a lengthy process, right? Let me show you a quick way you can check your answer. Isn't it nice to have a way to check your answers? Or to check an answer? Here's a quick way to check your answer. You listening carefully?
Let's see where that pesky thing comes from. So x times x, that's where the x to the, or x times x squared, that's x to the third, right? But then this x times negative 2x, that's a negative 2x squared. But then here you're going to have another negative 2x squared. That makes negative 4x squared. Let me do it in a different color. Did you get it? Did somebody step on a mouse over here? So let's go to your worksheet now. I'm going to help you with a few problems on your worksheet.
This number 13, this one I don't think you need a lot of help on because it didn't have any funky looking factors or zeros. So since these are all rational, there aren't any additional zeros to find. They're going to have conjugate pairs. So all you do is put them in the parentheses and multiply. You guys can do that one on your own. I don't need to show you how to do this one.
Okay. This is not where you would stop on number 13. You'd have to multiply this all out, but I believe we should spend time on maybe some more. Let's go to 15. This is number 15 on your worksheet. Same directions. It says find any additional zeros that might be there.
And then multiply it all out and come up with some polynomial.
So, are there any zeros that are missing? What do you think? This one right here is kind of funky. Negative I. It's going to have a pair. The conjugate pair would be positive I. Now you can put a plus sign in front of it if you want, but the absence of any kind of sign implies it's a plus sign. We have all three of the zeros here now. We next put them into factors. So, what are we thinking? First factor. You're thinking x plus 4? I don't know. It doesn't matter what I'm thinking. Is that what you guys are thinking?
Yeah.
All right, x plus 4. Actually, that only matters what I'm thinking, right? What am I saying? What about the next factor?
X plus I.
X plus I, and then x minus I.
Does it matter if the x plus I and the x minus I are like switched?
Doesn't matter. You'd end up at the same spot. Yeah. Because they have to come in pairs. The conjugate zeros theorem says any type of imaginary root or zero always has to come in a pair. Remember that theorem we talked about right at the beginning? This theorem right here. And then we practice finding all of these conjugate pairs, right? So any type of zero that looks funky like these always has to come in a pair. Does that answer your question? So, which ones are we going to multiply together first?
Last two.
The one involving the i's. X times negative I times x, and I times negative I.
X squared minus IX.
So what's going to be x times x is x squared. X times negative I is minus ix. I times x is positive ix. And then I times negative I is negative I squared. And what you really need to pay attention to is once you do this correctly, anything that has an I should cancel out. Anything that has an I should cancel out.
So it's x squared minus, actually it's plus 1.
Remember what I said about I squared?
Yeah.
I squared is negative 1. So again, you're subtracting negative 1.
So you're really adding 1.
So all that turns out to be is x squared plus 1. So this is what we have now. X plus 4
Times x squared.
And then with that, what happens?
Yep. You use the distributive property. You multiply it all together. Wait for it.
Wait, how in the world did you get that out of that?
The x squared plus 1.
because the I squared. Remember, I squared is really negative 1, and you're subtracting negative 1. That's where the plus 1 came from. And then those just canceled out. Is that what we're getting? X to the third.
Now, if you're just waiting for me to show you answers, that's great. You're going to have a lot of stuff on your paper that you have no idea how to do. Okay? You should be doing the work along the way. Okay? I show you the answer after the fact so you can check what you've already done. That's called practice. It's not practice if you write down what I did. You're just practicing writing down answers that isn't going to help. Right? Let's try 17.
That's all you gotta do? This one's the same type of thing, it just has square roots instead of i's, but you do the exact same thing. This is a rather unusual looking 0. It's an irrational. That means it has to have a pair. You're not just going to have 1 plus the square root of 3. What else are you going to have?
1 minus square root.
1 minus the square root of 3. So, we then place those into factors. And if you mess up on this part, the whole rest of it's messed up. You can't mess up at the very, very first step of the problem. So, what factor comes from negative 4 as a 0? What factor? X plus 4. Oh, I want you guys to stop for just a second. I'm going to write something that students do all the time. I want you to see if you can find their mistakes. I see this all the time and it drives me crazy. No X. Factors have to have X's in them. I don't know why that happens so often, but I do see it all the time. So, what kind of a factor is going to come from... Remember, if you imagine that this is X equals, you'd have to subtract 1 on both sides and subtract the square root of 3, if that helps. So it'd be X minus 1 minus the square root of 3.
Why is it X minus 1?
Because this is a positive 1. Really, I wish the worksheet had done it. I wish the worksheet had done it with X equals, because that's really what should be there. But you'd have to subtract the 1 on both sides. That's why it's X minus 1. To answer your question. So then, if this over here is another X equals 1 minus the square root of 3, then you'd have to subtract the 1, but you would add the square root of 3. So that factor is X minus 1 plus root 3. Okay, hang with me. We're almost done. Bell's going to ring in about 9 minutes, so just hang tight. Or it's 11:20.
It rings at the 30.
No.
No, 20.
I think it's 20.
Yeah, 12:45.
Yeah, 15 minutes.
Lunch short?
Lunch is way short, you guys. I wouldn't recommend leaving campus, right, Trevor? Okay. Anyway, we still have to multiply x times x, x times negative 1, x times that, and then let's start with that. I don't want to go too fast all at once. Let's just start with those first ones. X times x. Come on now. X squared. X times negative 1 is minus x. Now let's just be real clear on this last one here. X times the square root of 3. You cannot combine the x and the 3 together because this does not have a root. If you're multiplying two things that have the same root, then you can combine. All this would be is positive x times the square root of 3. That's all. You can't combine it because they're not like terms, really. So you just multiply x times the square root of 3. Now do the same thing with the negative 1. Negative 1 distributes here, here, and here. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. And then negative 1 times root 3. Negative 1 root 3 is technically correct. It'd just be easier to say negative root 3, though. And finally, with the negative root 3, that has to multiply the x, it's got to multiply the negative 1, and it's got to multiply the positive root 3. So, negative root 3 times x is negative x root 3. And then negative root 3 times negative 1 is plus root 3. Very good. Now, I'm just going to go off to the side here and do a couple of things that we went over last year briefly, but you might have forgotten. Square root of 2 times the square root of 3, or the square root of 5 times the square root of 6, or the square root of 2 times the square root of 2 itself. Let's just go real quick through some of these so you remember how to multiply two roots. What's the square root of 2 times the square root of 3? Square root of 6. Square root of 5 times the square root of 6? Square root of 30. So the point I'm making is if they both have square roots, you just multiply what's on the inside. That's all you do. So what's the square root of 2 times the square root of 2? Square root of 4, but then that equals 2. So if you're multiplying two identical roots together, square root of 2 times the square root of 2, what do you get out of that? Just 2. So is that the case here? We're multiplying the square root of 3 times the square root of 3. So that's the square root of 9, but the square root of 9 is just
3. But you got to remember, one of them here is negative, the other one here is positive. Negative. So all we're subtracting is a 3.
It's minus 3 at the end. That came from the square root of 3 times the square root of 3. That's the square root of 9. The square root of 9 is 3. Why is it negative? One's negative here, one's positive here. Negative times a positive is a negative. Anyway, doesn't a similar thing happen here? Any type of weird looking number with the root disappears. Negative root 3, positive root 3. Negative x root 3, positive x root 3. They're all gone. That's the nice thing about conjugate pairs is when you multiply them together, a lot of things cancel. So what are we left with? Ooh, careful. It's x squared minus 2x minus 2. This is what we're left with. And that multiplies another x plus 4. So we have x plus 4
Times x squared minus 2x minus 2. Go ahead and get on another try, multiply together. Isn't there?
Yeah.
Can I put this at negative 2x, right? Would you just change the I squared to 1 and then multiply the 2 times 1?
2 times negative 1.
Oh, right.
So then it'd be positive 2. Yeah.
not what we're getting. That's all it is, people. That's all you do is you find any additional roots, you put them in factors, you multiply the weird-looking factors together first, get rid of all the strange numbers, and then continue multiplying. Okay? This worksheet is going to be like page 1 of your next test. Okay? The next test is only going to have 3 pages, real short. Okay? All right, this will be like page 1.
I feel like this one's hard.
So, you have only like 3 more to do on your own, right? You have a little bit of time. It's not stopping time yet. Stopping time's on the bell ring, so finish as much of this as you can.